Properties of matter. You must observe matter carefully to be able to describe it well. Characteristics that help you describe and identify matter are called properties. Properties can be used to identify the kind of matter. Properties can be either physical or chemical. A physical property is a property that can be observed or measured without changing the composition of the matter. For example, if I had ice, which is solid liquid, solid water, and changed it to, heated it up to liquid water, it's still H2O. The particles are still the same, it's just the state is different. Physical properties are used to observe and describe matter. These physical properties could be subcategorized as either qualitative or quantitative properties. The hint in qualitative is it describes the quality and in quantitative it's the quantity of the matter. It's usually expressed in numbers. This is a chart describing the physical properties. This color, a matter can have a certain color or may not have any color at all. Texture, how it feels. Maybe you shouldn't be holding it. There's taste. The smell, the state, which is liquid, solid, or gas, the crystal shape, the malleability, which is how the matter reacts to bending. Metal can bend, but if I was to bend glass, it would shatter. And there's the ductility, which is how the matter reacts to stretching. Quantitative properties are like melting, the melting temperature, which is the opposite of freezing temperature, is boiling temperature, just as condensing temperature. The density is described as the mass over the volume. Viscosity is how thick the substance is. Like water is less thick than syrup. Solubility, the electrical conductivity, and the heat conductivity. Chemical properties. A chemical property is a property that you can observe when one kind of matter is converted into a different kind of matter. An example is a chemical property of iron is that it reacts with oxygen to form a different kind of matter, which is rust. Rust and iron have completely different physical and chemical properties. In chemical properties, they can be switched back, but a physical property, if I was to melt the ice cube into a liquid, I could freeze it back, but I can't get rust back into iron, regular iron. Things to look for when describing chemical properties are: does it react with water? Does it react with air? Does it react with pure oxygen? Does it react with acids? Does it react with other pure substances? What is its toxicity? Is the matter stable? And does it combust? This is a chart showing the physical and chemical properties as described before. Some are a bit different, but that's just because they're related to each other, maybe opposites. Changes in matter. Properties can change. Example, ice can melt and paper can burn. Changes in matter can be placed in two different categories. There's the physical change and the chemical change. Ice melting is a physical change, but paper burning, that's a chemical change. Because when the ice melts, I could always freeze it back, but for the chemical change, which can't be brought back or very hard to be brought back, I can't bring the paper to its first state. Physical change. In a physical change, no new substance is formed. New properties may appear, but the particles of the starting substance or substances are not changed. Example, ice melting into water. If they all have the same particles, physical changes can be reversed. Example, water can be frozen back into ice. An important rule is any property that can be measured or observed without forming a new substance is a physical property. Chemical change. Chemical changes always cause at least one new substance with new properties to be formed. A chemical change may be difficult or impossible to reverse. Example, paper burning. Understanding changes in matter is very important. For example, building a spacecraft. Will the material melt in extreme heat or become brittle in cold or react with other materials? Here we'll be talking about properties of helium and hydrogen. Both helium and hydrogen are both colorless, but the density of helium is more than the density of hydrogen. Therefore, the hydrogen is lighter. Both the color and the density are physical aspects, but the combustibility is a chemical. Helium doesn't burn, hydrogen burns. We use helium in balloons because it's safer, and it was the incident of the Hindenburg where it was filled with hydrogen because it's lighter, but they didn't take their precautions and it caused the Hindenburg to explode. These are the rules for chemical changes. If you make two or more of the following observations, then a chemical change has probably taken place. Is heat being produced or absorbed? Is the starting material being used up? Has a new color appeared? Has the starting color disappeared? Does a material with new properties form? Do gas bubbles form in a liquid? Do the grains of the solid precipitate form in a liquid?